Picture yourself driving across a bridge over the open ocean. Water stretches to the horizon on both sides. And then, in the middle of the sea, the road ahead simply dives underwater. The bridge vanishes beneath the waves, becomes a tunnel, carries you along the seabed while ships sail overhead, and then rises back out of the ocean on the other side and turns into a bridge again. This is not science fiction. This is a real road in China, and millions of people drive it. It's the Hong Kong Zhuhai Macau Bridge, 55 kilometers long, the longest sea crossing on Earth. And to build it, engineers had to solve a puzzle that sounds impossible. How do you build a bridge across the sea without blocking the thousands of ships that need to sail right through it? Here's how they did it. Now, watch why they even needed this.
Look at the Pearl River Delta in southern China. It's one of the most crowded, richest, busiest economic regions on the entire planet.
On one side sits Hong Kong. Across a wide stretch of seas sit the cities of Zhuhai and Macau. They're close as the crow flies, but between them lies a huge mouth of open water where the Pearl River pours into the sea. For decades, to get across, you had a choice: a ferry ride of several hours, or a massive road detour all the way around the water. Two of the most important economic zones on Earth, sitting right next to each other, cut off by the sea. So China makes a decision: connect them directly, throw a road straight across the ocean. And this dream is older than you'd think. The idea of physically bridging this delta had floated around for decades, proposed, studied, and shelved again and again, because for the longest time it was simply too hard and too expensive to be real. The water was too wide, too busy, too deep in soft mud, too battered by storms. It stayed a fantasy on paper while ferries chugged back and forth for generations.
It only became possible when China's engineering muscle and ambition grew big enough to stop asking, "Can we?" and start asking, "How fast?"
What was impossible for a century suddenly had a start date. But here's the immediate, brutal problem. That stretch of sea isn't empty. It's one of the busiest shipping lanes in all of Asia. Gigantic container ships pour in and out of these ports day and night. You cannot just build a long, low bridge across the water, because a low bridge would be a wall, blocking those enormous ships from passing. And you can't make the entire bridge tall enough for the biggest ships either, because right next to this water sits one of the world's busiest airports. And you can't have towers stabbing up into the flight paths. So you're trapped. Too low, and you block the ships. Too high, and you block the planes. It seems unsolvable. And that trap is exactly why this crossing is so ingenious. The engineers said, fine, where the ships need to pass, we won't go over the water, we'll go under it. For most of the way, it's a bridge. But at the busiest shipping channel, the road dips down, disappears into an undersea tunnel.
This is an engineering marvel, an underwater tunnel that runs along the seabed. Giant ships sail safely overhead while vehicles travel below. The tunnel then climbs back up into a bridge on the far side.
A crossing that is part bridge, part tunnel, switching between the two in the middle of the open sea. Now the numbers, because they're staggering. The whole system is about 55 kilometers long, roughly 20 times the length of the Golden Gate Bridge. Of that, a stretch of about 6.7 kilometers is the undersea tunnel. It used around 400,000 tons of steel, enough to build roughly 60 Eiffel Towers, and it was engineered to survive almost anything the region can throw at it. Designed to last 120 years, to withstand a magnitude 8 earthquake, a super typhoon, and even a direct hit from a 300,000-ton ship. On paper, madness. All they had to do was build it, and before anything else, understand the enemy this whole crossing had to survive: the weather. This part of the world sits directly in the path of some of the most violent storms on the planet.
Super typhoons roar through here, packing winds strong enough to flip trucks and tear roofs off buildings.
A 55-kilometer bridge standing out in open water is completely exposed to them. And these weren't just a design worry on paper. During construction and after opening, real monster typhoons slammed into the region with winds well over 200 kilometers an hour. The bridge had to be shaped and strengthened to take that full fury and keep standing, year after year, for over a century. Every tower, every cable, every deck section was engineered with that howling wind in mind. So let's start with the bridge part, because even that is not simple. This isn't solid ground. The seabed here is soft marine mud, and the water is wide open and lashed by typhoons. To hold up a bridge across kilometers of that, engineers drove huge foundations deep down through the mud into firmer ground below, then raised the bridge deck on top. And to let medium-sized ships pass in certain spots, parts of the bridge rise into tall, cable-stayed sections. towers with cables fanning out to hold the deck, some shaped like giant Chinese sailing ship masts, a nod to the region's seafaring history.
Kilometer after kilometer of roadway, marching straight out across open water. But here's a clever trick that made the whole thing possible. They barely built any of it at sea.
Building out on the open ocean, in typhoon country, on a rocking boat, is slow, dangerous, and unreliable. So instead, the engineers built the bridge in giant pieces in factories on land. Enormous sections of deck and colossal steel foundations were manufactured on shore, in controlled conditions, then carried out to sea by some of the largest lifting ships in the world and slotted into place like the pieces of a Titanic model kit. It's the same philosophy as prefab construction, just at monstrous scale. Turn a chaotic ocean building site into a calm factory assembly line, and only do the final snapping together at sea. And the sheer scale of that factory work is hard to imagine. Remember that 400,000 tons of steel, 60 Eiffel Towers worth. All of it had to be cut, welded, and assembled into precise, enormous components before ever touching the water. China essentially built dedicated industrial plants just to mass-produce bridge parts for this one project.
This factory is churning out massive steel bridge segments on a production line. It's just like a car factory, stamping out identical cars. The scale of production here is incredible.
This standardized factory-style approach is a big part of how they built something this colossal in under a decade. It wasn't just a construction site. It was an assembly line for a 55-kilometer machine. Now to the real showstopper, the tunnel. And to build the tunnel, they first had to solve an even weirder problem. Where does the bridge actually turn into a tunnel? You can't just have a road plunge off the end of a bridge straight into the sea. You need a solid place for the road to transition from up on the bridge down to the tunnel on the seabed, a doorway between the two worlds. But out there in the middle of the ocean, there is no land, so they made some. The engineers built 2 artificial islands from scratch, right in the open sea, one at each end of the tunnel. Each island is around 100,000 square meters, and they built them using a brilliant technique for speed.
Instead of slowly dumping rock and sand until an island rose out of the water, which takes years and disturbs the seabed enormously.
They took gigantic hollow steel cylinders, each one enormous, drove them down into the seabed in a ring, and then filled the ring with sand. The steel cylinders form an instant wall, a container, and the sand inside becomes the island. They planted these steel rings and had the shells of 2 islands standing in the sea in a matter of months, not years. 2 brand new islands, born in the ocean, purely to be the on-ramps for a tunnel. Now the tunnel itself. And this is where the engineering gets truly wild. They did not bore this tunnel through the rock under the sea. They built it the way you'd build the Hong Kong Harbor Tunnel, the immersed tube method, but at record-breaking scale. They cast the tunnel in giant concrete sections on land, 33 of them. And each one of these sections is a monster, as long as a skyscraper is tall and weighing around 80,000 tons. 80,000 tons, heavier than a large aircraft carrier, for a single section.
Here's how a section that heavy gets placed. First, they seal its ends and float it, because a hollow sealed concrete box, even one this enormous, displaces enough water to float, just like a ship.
They tow this floating giant out to the exact spot. Meanwhile, on the seabed below, a trench has been dredged and leveled with incredible precision. Then they let water into the section's ballast tanks, and it slowly, carefully sinks, dropping to the bottom of the sea and settling into place, right up against the previous section. And they have to align it to within centimeters, underwater, in the dark, in strong currents. Do that 33 times in a line, and you've laid a road along the bottom of the ocean. But sinking them is only half the battle. The joints between the sections have to be perfectly watertight, because on the other side of that concrete is the crushing weight of the entire sea, forever. So the ends are fitted with massive rubber seals. When a new section is pulled tight against the last one, they pump the water out of the gap between them, and the immense pressure of the ocean itself squeezes the 2 sections together, crushing the rubber into a perfect, permanent seal. The deeper it is, the harder the sea pushes, and the tighter the joint becomes. The ocean, trying to break in, is turned into the very force that keeps it out. And there was one final nerve-shredding step, the last piece. After laying most of the sections from both ends, engineers had to drop one final closing section into the remaining gap deep underwater and connect it on both sides at once.
A maneuver so delicate it was compared to threading a needle at the bottom of the sea. When that last piece locked into place and the tunnel was watertight from island to island, the road under the ocean was finally complete.
And think about what it's like to actually drive it. You're cruising on a bridge over open sea, and ahead you see one of those artificial islands rising out of the water with the tunnel mouth in it. The road tips downward, daylight disappears behind you, and suddenly you're driving along the bottom of the ocean, with the weight of the sea and the hulls of passing ships somewhere above your roof. For those few kilometers, a hidden system is quietly keeping you alive. Powerful ventilation, pumping fresh air in and hauling exhaust out, sensors watching for any sign of fire or trouble, and emergency exits ready. Then the road tilts up, the second island appears, and you burst back out into the sunlight and open sky, back onto a bridge, as if nothing happened. Most drivers barely register the miracle they just performed. On the 24th of October, 2018, after nearly a decade of construction, the Hong Kong Zhuhai Macau Bridge opened, and the effect was instant. That trip that once took a 4-hour ferry ride now takes around 45 minutes by car. Three of the most powerful economic cities in the world, once separated by the sea, are now stitched together into a single super region, connected by a road that dives beneath the ocean and comes back up the other side. And that's the real point of the whole thing. This bridge isn't just a shortcut. It's the physical spine of what China calls the Greater Bay Area.
A plan to weld 11 cities around this delta into one giant interconnected economy, meant to rival places like Silicon Valley or Tokyo.
When a truck full of goods can cross from Zhuhai to Hong Kong's port and airport in under an hour instead of half a day, entire supply chains speed up. Factories, ports, finance, and tourism all get pulled closer together. A bridge across water is really a bridge across time, collapsing hours into minutes and turning three separate cities into neighbors. But a project this big always has a cost beyond money, and it's honest to say it. The waters of the Pearl River Delta are home to a rare and beautiful animal, the Chinese white dolphin. Building a 55-kilometer megastructure through their habitat put real pressure on these vulnerable creatures, and their numbers in the area have been a serious concern. Engineers took measures to try to protect them during construction, but it's a reminder that even our greatest works of engineering are built inside a living world, and they leave a mark on it. Every triumph over the sea has a price attached, and it's not always paid in dollars. Here's the bottom line. Engineers were handed an impossible contradiction. Cross the sea, but don't block the ships, and don't block the planes. So they refused to pick just one answer. They built a bridge where they could, sank a tunnel where they had to, and conjured two islands out of the open ocean to join the two together. They prefabricated a 55-kilometer machine on land and assembled it at sea. And they used the crushing weight of the ocean to seal the very tunnel meant to keep it out. They didn't beat the sea with brute force. They outthought it, section by section, island by island.
The diving under the sea is one thing. What about the crossings humans straight up and down? It's an airport, an island that sinks a little more here, and center story we break down here. See you at the next impossible structure.